between the concept of work, conservative forces and potential energy, as well as the transformations between kinetic and potential energy. Let's take a look at this question. A system of two bodies, A and B, are connected by an inextensible cord over a frictionless pulley and are resting on inclined planes, as shown in Figure 6. Body A of mass 2 kg and body B of mass 5 kg move in the directions as indicated. A distance of 0.5 meter and each experiences a frictional force of 3 Newton. Part A is to calculate the change in gravitational potential energy of the system. Now, how should we proceed to attempt this question? The question asks for the change in gravitational potential energy of the system. Now, this system consists of two bodies. Therefore, we have to find the change in gravitational potential energy for body A and B respectively. And since we know that the formula for GPE is equal to mgh, it's very crucial that we find the change in height for both body A and B after sliding. So let's proceed to find this change in height for body A and B. Let's start with body A. So body A slide upwards 0.5 meter as shown, whereas body B slide downwards 0.5 meters as shown. So A experiences a rise in height. So let's indicate this in the diagram. So A experiences a rise in height, while B experiences a loss in height. As you can see. So body A is inclined at an angle of 40 degrees, whereas body B is 50 degrees. I'm going to call this rise in height for body A, change in height for A, and that for body B as change in height for body B. Can we find change in HA and HB respectively? Yes, by using a simple trigo function. Now, we know that hypotenuse of this triangle is 0.500 meter. The same goes for body B, this one 0.500 meter. So focusing on the right angle triangle that we see here, and for this one, well, we can proceed to solve for the change in height for body A and B respectively. I'll just do for body A. So using the trigo function, sine 40 degrees will be equal to change in height of body A divided by the hypotenuse of 0.500 meter. So the change in height for A will be 0.500 times sine 40 degrees. So similarly, change in height for body B can be found in the same way. So it will be 0.500 sine 50 degrees instead. With the respective change in height found, we may proceed to find the change in GPE of the system. So, change in GPE of system is actually equal to change in GPE of body A plus the change in GPE of body B. It's a sum of change in GPE for the two bodies. Now, change in GPE of body A from the formula mgh, we put it as ma, mass of A, times G times the change in height for body A. The same goes for body B. So we'll write it as mg, change in height for body B. Now let's substitute all the values that we know. The mass of body A is 2 kg. G will take it as 9.81. Change in height of A, let's substitute in 0.500 sine 40 degrees. For B, it will be 5 kg, 9.81. But because body B experiences a drop in height, so the change in GP of body B is actually a negative value to denote that it is a loss. So we have to put a negative sign for the height, 0.500 sine 50 degrees. Body A experiences a gain in height, so there is an increase in GPE for body A, whereas body B experiences a decrease in GPE. Hence, body B has a negative value for the change in GPE, while body A has a positive value for the change in GPE. Adding all this together, we'll have the total as negative 12.481 joules. And rounding off to 3 significant figures, we write it as 12.5 joules. So let's write as 3 SM. Now, how should we proceed to solve the second and final part of this question? Well, the question asks for the final speed of the system after traveling 0.5 meter per second. Now, from the previous part of the question, we know that there is a loss in GPE in the system. And we know that from the principle of conservation of energy principle, this loss in GPE must be converted into another form of energy because energy cannot be lost or destroyed. Hence, from the question asking for the final speed, we can deduce that part of the GPE becomes the gain in KE of the system. Before the two bodies starts to travel along the planes, please note that they are resting on the inclined planes, meaning the initial KE, kinetic energy of the two bodies, is 0. Now, is all the GPE loss converted into gain in KE? No. There is another form of energy that we need to identify in the question. What is that energy? The question mentioned there is a frictional force of 3 Newton. So, part of the energy lost in GPE goes to overcome the frictional force. So, some of the GPE used to overcome friction. Therefore, the GPE is converted into two forms of energy. One is gain in KE, the other one is heat produced due to friction. So let's write the principle of conservation of energy formally in an equation. You can say that the loss in GPE is equal to the gain in kinetic energy, or KE, of the system plus the total work done against friction. Now, how do we calculate the work done against friction? Take note, we are calculating work done against friction, not work done by friction. So we have to identify the forces There's overcoming the friction. So let's say friction X in the opposite direction of motion to A, and let's call this F. And similarly for B, it acts in the opposite direction of motion for B, and we call it F. There is a forward force pulling A upwards. So let's call this force FA. And at the same time, there is also a component of the force pulling B downwards in this direction. We call that FB. FA and FB are two forces that overcome the friction experienced by each body. To just overcome friction, we can say that the magnitude of force A is actually equal to F. And similarly, the magnitude for FB is also equal to F to just overcome the friction. So the work done against friction is actually the work done by force FA and FB respectively. So let's write that down formally in the equation. The loss in GPE we already calculated from the previous part is 12.481. Take note the negative sign is removed because we are now talking about a loss. We're not talking about a change. When we're talking about change, negative sign would tell us that it is a loss. Since we are writing it as a loss, the negative sign will be omitted. Then the gain in KE is half combined mass M V squared minus half M U squared. V is the final speed of the system, where U is the initial speed of the system. Then work done against friction is force times distance in the direction of force. So FA times D plus FB times D. So these are all the variables that we know in the question. Let's put in all the values. So we will have 12.481. Combined mass of M is actually mass of A, which is 2 kg, plus the mass of B, which is 5 kg, times B squared, the final speed of the system, which we don't know yet, and minus half combined mass plus 5 times 0, because the initial speed of the system is 0. Then we plus, now force FA is actually equal to the frictional force, so it's 3 Newton, times, now the distance traveled in the direction of this force FA is 0.5 meter. And the same thing occurs for force B. Its magnitude is also 3 Newton times the distance traveled, which is also 0.500 meter. So rearranging this equation, we have half combined mass of 7 kg V squared will be equal to 9.481. So upon solving for B, we'll have V to be 1.65 meter per second, round off to 3 significant figures. And with that, we have solved the question. I hope from this example of work and energy, you will be able to appreciate the principle of the conservation of energy and how we can use it to solve questions of this manner. Thank you.